4, 3, 2, 1. We're live. Hi, everybody. Welcome to the Frosty Drew Observatory and Science Center's Stargazing Nights live event. Tonight, we're live streaming again because we're supposed to be getting Tropical Storm Faye and was going to bring heavy rain and thunderstorms and high winds, though we haven't really had too much of that happening yet for us. Regardless, it's cloudy, so we would not be able to observe anything through our telescopes. So we figured instead of just closing up tonight, we would do a 1-hour live stream. So you guys sitting at home, weathering whatever storm you may be experiencing, can get a little catch up on some of the cool things happening in Astro. Now, tonight we have a few people on board. We have 2 astronomers. We have Derek Schott coming to you from Connecticut. We have myself, Scott McNeil, coming to you from Providence. And we have our intern from this summer, Mara de Cesara, with her cat, coming to us from Rhode Island. And then Jessica is going to be moderating tonight's event for us. Now, if you take a look at your screen, right on the right-hand side, you're going to have your chat window. That's a place where you can have discussions about what we're talking about. And you can also pose questions to the moderator, who will then repeat your questions on the air for our astronomers to answer. Now, it's been a cloudy week, it's been a cloudy couple weeks, and the moon has been out, so we're not doing a lot of data collection at this time, though we do have a few things we want to show you guys. And as we're stepping into the time of year, or at least this year, when the planets are starting to become a big deal, Jupiter is rising earlier and earlier every night. Saturn is in conjunction with Jupiter, so they're together in the sky, and Mars is going to be all the rage. We're going to show you some of our raw data sets that we've captured from the planet this year. They're raw data sets. They're not processed, so they're not going to be as spectacular as it would look if you actually saw them in the telescope with your own eyes. And additionally, we're going to talk a little bit about Comet C2020 F3 Neowise, which has been getting a lot of noise tonight, and just lately with how fantastic it's become in the morning sky. I wanted to make one quick note before we continue, and that is about our Stargazing Nights events. Now, if anyone who is with us tonight has been trying to get tickets for our events and are finding it a bit cumbersome, we're going to explain it real quick. So the reason why we don't post our ticket acquisition links to our events pages at all times is because the events are selling out very quickly. Our last Stargazing Nights event, when we were still capping our events at about 50 visitors, sold out in under 50 minutes. Now, if we posted the links earlier, like they were there all the time, then our events would all sell out way beforehand. And then everyone who bought tickets would get the shaft if it was cloudy. And it's New England. I mean, it's cloudy all the time. So, and we're on the coast. We've had a lot of fog this year. You guys have probably stepped outside and realized how humid it is. And once those temperatures start dropping at night, that humidity just condenses in the air and it fogs right up. So we want to make sure that you guys aren't kind of getting shifted out of your money. Now, the other reason we post links late is because we also want to make sure that when we're putting out our newsletter, which is on Fridays, when we're talking about our events, kind of getting everybody going on Friday, we want to make sure that we're actually promoting events that aren't just sold out. So we're going to be posting ticket acquisition links usually on the day of the event. But now that we can handle a higher number of visitors, because Rhode Island is now in phase 3 of reopening, we'll be able to post the links a little bit earlier. We also have an event tomorrow night called Celebrate the Milky Way. This will be our 3rd Celebrate the Milky Way event for 2020. And the weather is not looking spectacular, though it is looking better than tonight. And we're going to closely monitor weather over the next 12 hours, 14 hours, and kind of see what it's going to do. And if it's not clear enough to host a Milky Way event, but it is clear enough to still observe through the telescope, then we're going to open it anyway. And we're just going to host a regular Stargazing Nights event so you guys can get a chance to come out. And we will post links to get tickets to the event page tomorrow, late morning or early afternoon. So you want to make sure you're checking our events at frostydrew.org. And it's the event called Celebrate the Milky Way. So, Derek, do you have anything you want to show quick, or do you want me to start showing stuff?
I mean, I can start. I've got Stellarium up. I'm just doing a kind of virtual view of what the comet's going to look like in about 2 weeks in the evening sky. And then I was going to talk about what we are seeing right now with it way low in the morning sky.
Cool.
So I can remember where the present button is.
While Derek's getting it up, it's important to note that this comet it goes by a few different names. Some people call it Comet F3. Some people call it Comet Neowise. Some people call it the Morning Comet. This is Comet F3 Neowise. And this comet is getting a lot of noise right now because of all the comets we've had this year. This is the comet that has actually become naked eye visible. Now, it is in the morning sky, and we've been hammered with clouds and fog lately, so it's definitely affecting our view. But images of the comet from all over the world are starting to become very commonplace on the web. And we're getting a lot of write-ins about people asking to see the comet. We're going to keep an eye on it very closely, and we're going to be publishing finder charts to our Facebook page, which is just facebook.com/Frosty Drew Observatory. You can also get to it from our website, and that will help you know where to look in the sky. Now, Derek's going to show you, too, a little bit about it, because it's going to be getting better over the coming weeks. Go ahead, Derek.
All right. So I've got kind of a future view going on right now. This is July 23rd at about now 8:44 in the evening. So you can see here in the middle of the screen is the center point of the C2020 F3 Neowise comet. And it's in kind of the lower portions of, or maybe the back legs of Ursa Major. So if you're familiar with the Big Dipper, the asterism, the Big Dipper is this object here. And then the comet is about, I don't know, we'll call it halfway to a third of the way over to Leo the Lion. So that'll be what it looks like, you know, in about 2 weeks. We'll come back to that, but we'll switch over to what it looks like right now in the morning. So we'll switch to, you know, the right date, which is today, and then we'll go to the right area of the sky, and obviously it's very low in the sky. And then if we kind of wait until the morning, let's go till, here we go. You can kind of see how it's, you know, just barely above the horizon, but you can see how much it's moved in that 2 week period. Right now, it's off the front of the bear, Ursa Major, whereas in 2 weeks from now, it's going to be underneath the bear. So that gives you an idea of how much the comet is moving in the sky in that 2 week period. We can kind of like, you know, translate and see how it moves underneath the Big Dipper and then becomes more of an evening object. We'll switch over to back to the evening and go that area of the sky again. Sorry, it's kind of clunky, but it works. Oh, there's Leo. And then even over the course of a couple of days there, you can see how much that comet's moving. It's almost moving as much as the moon moves. So it's really moving across the sky. And why I picked the 23rd to start on is that's when the comet makes the closest approach to the planet Earth. So we're hoping to have a good show around that date. I didn't even look at a calendar to figure out what the 23rd was, but it's probably a Thursday, given that today's the 10th. Yeah, so that'll be one. So the 24th will be our planned, you know, astronomy night on a Friday at Frosty Drew. So hopefully the moon isn't too much of a problem, and we'll be able to see the comet coming up in about 2 weeks.
Now, over the last couple weeks, Comet Neowise has been emerging from the sun. It was July 3rd that Comet Neowise was at perihelion, which is when it makes its closest approach to the sun. And perihelion for Comet Neowise was quite close. It was substantially less than an astronomical unit, and it was somewhere around 24 million miles distant from the sun. And that really exposes that comet to some pretty intense solar radiation. And a lot of speculation and expectations for the comet were that it wasn't going to survive its perihelion being that close to the sun, though it did. And it's gotten exceptionally bright. Right now it's about magnitude 1.7, which is easily naked eye visible. And the reason why comet Neowise survived that close perihelion is because the nucleus on that comet, that rocky core of the comet, is a bit larger than the average size of a comet's nucleus. When we look at comets that come through, the nucleus is usually somewhere around up to a mile in diameter, where comet Neowise's nucleus is about 3 miles in diameter. So what's happening is it's really enabled it to stay intact, and that larger area is got a lot more outgassing, and that's what's made it so bright. So that was very nice that it stayed together, because you think about all the comets, Comet Atlas and Comet Swan, and there was another comet earlier this winter as well that they didn't survive their, what was it, K2 Pan-STARRS, I think? They didn't survive their perihelions because they just didn't have, the nucleus was too small and the solar radiation was just too intense. But if you have a moment, Derek, I'm going to switch over real quick and show the A-pod for today.
Sure.
So this here, this is an image of Comet Neowise from just this past week, in fact, probably the past couple days. This was captured by Emmanuel Pauly, and this was captured in, I believe this is France. Now, this is in the morning sky. You can see those clouds in this image. Those are actually called noctilucent clouds, which are a little bit different than the clouds we're used to seeing. These clouds are only visible about 45 minutes to an hour before sunrise or 45 minutes to an hour after sunset. And what they are, they're clouds that sit in Earth's mesosphere. Like, we're talking towards the outer edge of the atmosphere. And what's happening is you have, convection is pushing a lot of like that humidity, a lot of that moisture up into the mesosphere, and you have all this little comet particles, like meteor particles, little pieces of dust that are in the atmosphere, like tiny, tiny pieces. And it's from all that meteor activity we deal with throughout the day. And water vapor freezes to those particles, and we get these really wispy, iridescent clouds. And they kind of flare up in the summer in the northern hemisphere. We call it noctilucent cloud season. Now, in this image, you can see right here, Comet Neowise is really, putting on quite a show. And the reason I think this might be earlier than today is because in this image, I only see one tail right here. And over the last couple of days, Comet Neowise has formed a really fantastic ion tail as well that kind of shoots off in this direction. You can notice how bright the nucleus is on Comet Neowise. And some of the other stars you see in this image here, these are stars that you would just faintly see with the naked eye. And from my understanding, the naked eye view of Comet Neowise at this time appears as a blurry object in the sky that has a tail behind it. So we haven't had a chance to see it here yet, but we are optimistic that we will get a chance quite soon.
Scott, just to clarify for people who might not be aware, but what's APOD mean?
APOD stands for Astronomy Picture of the Day. And it's put out by some scientists. Some of them are NASA scientists. And they do it on the side. It's not part of their job. It's kind of like a hobby that they do. And they kind of they have themselves and other people that help them out scour the web looking for really awesome astronomy-related pictures most of the time. And they'll post one every day. And I think APOD's been going for almost 20 years now, right? I think it's about 20 years now. One of the individuals that operate the Seagrave Observatory in North Scituate, his name is Jim Hendrickson, actually had one of his images of the moon published as the Astronomy Picture of the Day sometime back in, I think, 2009. I'm yet to get an astronomy picture of the day. We'll see.
Lots of competition.
There is. And you know what? It's not really about the best images. I think it's about the best images that they find. Because I've seen some pictures of Comet F3 Neowise that are just, they're fantastic. And I'm going to try to pull one up real quick. I'm not going to download it because I don't have a license to download this picture. But this was posted, this looks like this was posted today. This is from Australia. And this really is like, this is an amazing view of this comet. Let me see if I can get a good, yeah, it's a little too big. So I'm going to go back. So right here, I'm going to share this with you guys right now. And this is what I was talking about what it's starting to look like now. Now this image here is taken with a wide field telescope. So this is not necessarily going to be what you're going to see in the sky, but hopefully this is something that we're going to start seeing pretty soon in our sky here. I mean, when we start taking a look at it at Frosty Drew. I mean, just take a look at this image here. You got the nucleus is just, the amount of outgassing that's happening here is just ridiculously bright. You can see that there's actually some formations in the tail, and you got a couple tail disconnects happening. The tail disconnects are usually products of events in the solar corona, coronal mass ejections, magnetic storms, any kind of magnetic disruption in the solar wind will interact with that comet, and it will kind of blast the tail off, and it forms a new tail. That's the disconnect there. Here's the ion tail right here, and you have some excellent disconnect activity right in here. I mean, when I saw this image today, I got excited because all the other ones, I was like, yeah, it looks all right, but it looks like it's kind of messy. But this image here tells me that we might actually get a fantastic ion tail that forms with this comet. And what's really awesome about Comet Neowise is if you think about the angle that Comet Neowise is approaching Earth from, I'll see if I can pull it up real quick here. It's all about angle, because what
Well, that would be Scott's computer crashing when he tries to do something fun. Happens a lot. So I think what Scott was going to show us was how the comet is orbiting the sun such that it presents to us to be a good view of the comet. Whereas in an earlier session, we were talking about how the southern hemisphere has gotten more comet activity than the northern hemisphere this year because of the way comets have come into the solar system from below the sun, if you are thinking that the north pole of the Earth is up, whereas Neowise has come in at an angle that is more advantageous for the northern hemisphere.
Yeah, so like I was saying before, and Derek was saying that Comet Neowise, when it went around the sun, it went around the other side of the sun that we're on, but because of its inclination, its tilt to the plane of the solar system, it's swinging right over top of us. So we're going to be able to see the nucleus with the tail behind it or in front of it from our point of view. So we're actually going to get that view from where we're at. And that's awesome. It's been a while since we've had a comet this bright that we can do that with. I was trying to load up an app called In the Sky. Derek tried earlier in our pre-session and it wasn't working. And I just realized it wasn't working too, and I used the wrong window. I actually used the window I was in the chat with. So go Scott.
You navigate away from our meeting here. Yep, you'll disappear.
Now, we also have been getting a lot of questions about, are we going to observe Comet Neowise at Frosty Drew? So the short answer to that is, yeah, absolutely. Are you kidding me? But the long answer, or the more involved answer, is that we will be observing it, but not necessarily right now with the public, because it's a morning comet. And all of our public events are generally at night, because I really don't think we're going to get too many people coming out at 3 o'clock in the morning to gear up to see the comet, only the geeks. But once Derek was showing you before, once Comet Neowise moves into the night sky, then yeah, we're going to become a regular showpiece at Frosty Drew. So,
and it's in a pretty good location. The Big Dipper in the eastern sky is pretty good. It's a little bit outside of the westerly light dome, so we should have pretty good view of that.
Right, and when we're talking naked eye visible comet, like, yeah, the less light pollution is always going to be great, but it's not going to be like looking at a galaxy where it's going to be a make or break kind of thing. So, I mean, we're dealing with a comet that you can actually see the tail naked eye. I mean, you think about all the comets you may have seen at Frosty Drew over the last 10 years, and though we can capture the tail with our cameras, capturing the tail visibly in the telescope is not as easy. So this comet, totally different story. And with that said, I want to show you real quick a couple pictures of comets that we've seen at Frosty Drew in the past. I mean, comets are really, once you get a good comet around, they become quite the rage. And everyone starts talking about, comet of the century. I don't think that Comet Neowise is going to be that, but we still could have a really great time with this comet. Now, this was comet. Go ahead.
So Oscar is back tonight, which is really cool. He is asking a question that said, how long will the comet be visible in the sky?
So how you doing, Oscar? It's good to see you back. That's a tough question to answer because it depends on how long it keeps outgassing. It depends if it stays intact. It depends if that comet fractures. So what happens is if Comet Neowise will probably be naked eye visible for a good month from now before we start to really dim back down. That's if nothing happens to it. Now, there's a good chance that Comet Neowise, being a long period comet means we don't see it very frequently, could fracture. And if the nucleus does break, then it's going to outgas substantially. And this is called an outburst. And this will allow us, it'll look amazing in the sky for a period of time, but we'll lose it faster. And that's kind of what happened with Comet Swan and Comet Atlas, which I have up right now, is they underwent outbursts and they became substantially brighter than we expected. But as a result, they faded out and fizzled off much quicker than we expected as well. And they kind of came up a little short of that show. So if Comet Neowise stays intact, I'd say for a good month, we'll have it with a peak period of brightness in about 2 weeks. So in this image here, we're seeing Comet Atlas, and this was taken earlier this year. This was a collaborative project between myself and Robert Horton from Brown University. And we did this for the Physics 220 lab. In this image here, this is largely the comet's nucleus in the center with a green glow around it, which is called a coma. And that's the atmosphere that forms around the comet. And you can just see a little bit of a hint of a tail here. And again, this is because Comet Atlas, its tail was largely on the opposite side of where we see it from because of how it approached the sun. And that's the same. You guys remember Comet Wirtanen from what was it, 2 years ago? It was a winter comet. We had it for Christmas. And this is it right here. This was an image we captured at Frosty Drew. And again, you can see this fantastic coma on this comet. It got very bright and it just reached naked eye visibility as a faint blurry spot in the sky. But again, this comet is tails on the opposite side of where we see it. So we just see that big atmosphere that forms around the nucleus. In the case of Comet Wirtanen, though, Comet Wirtanen's atmosphere became almost as big as the sun. I mean, that's formidable considering that the nucleus is 1 mile in diameter, 0.75 miles in diameter. I mean, it's quite an atmosphere that forms around it. And this here this is going back to 2016. This is Comet Catalina. And Comet Catalina put on quite a show for planet Earth. But for some reason that year, we had so much cloud cover, and this is January, that we were only able to get it one night, and this was the night during the quadrantide meteor shower. This is the bright star Arcturus in the constellation Boötes. And this was when the moon was up. And this is the best we were able to do. And even that night, we only had a small window of opportunity to actually capture the comet. But in this case, too, it's really nice. You have a couple things happening here. First of all, you have a nice dust tail on the comet. But what you see here is called an antitail. An antitail is when the comet actually leaves behind a very dense debris field as it moves out of the solar system or moves out of the inner solar system. And that debris field is bright enough to actually reflect enough sunlight to see it. And we call that an antitail. And now that Comet Neowise is on its way back out, it very possibly could form an antitail, which even though it goes, once we lose naked eye visibility, that anti-tail could become quite big. I mean, think of comet, what was it, L2 Pan-STARRS back in 2011, I think. That comet was great. It was naked eye for like 2 days in Rhode Island. We got some good views of it, and then we never even forgot about it. And then about 3 months later, it formed a 10-degree long in the sky anti-tail. And then this was probably the last really great comet we had. This is Comet Q2 Lovejoy. And we captured this over a series of different nights. So this is earlier in a comet's evolution. You know, you have the nucleus, you have the bright coma, and you got a really nice tail on this guy. But when this chick started to grow, the tail became really spectacular. This was about a week later. And in this case, there was several disconnects that have left remnants of all different types of tails here. And the coma is growing as well in this image. And then we captured it wide field one night as it kind of cruised on past the Pleiades. And that's right here. And then you can see the tail has grown quite significantly. In this image here, that tail's about 7 degrees long in the sky. This comet was barely naked eye visible. Like at Frosty Drew in the darkest nights, you can just kind of see a hint of the comet. You couldn't see the tail. But telescopically, the comet was beautiful. And then before the comet started to fizzle out, this was the best image that we were able to get of it when it really kind of took off. You know, the coma got huge and the tail just really fanned out. And we would have liked to have gotten a longer or more of a mosaic or panoramic image of this, because the tail at this point was so dramatic. And these are just some of the comets that we've seen over the last decade at Frosty Drew. And Comet Neowise will probably be the best one that we've seen in the Northern Hemisphere since what? Comet Hale-Bopp, Derek?
Probably. Trying to remember when that one was. That was late
97.
90s? Yeah.
That was 97. And it was right before that, like 95, maybe 96, was Comet Kohoutek, I think it was.
Yeah, I remember that one too.
So
that was pretty crazy. It made me think that was going to be normal, and then we haven't had one for 25 years.
I know we're kind of overdue if you think about it. I mean,
yeah.
And all the Southern Hemisphere, that's a whole other story. I mean, they got, what was it, back in 2011, they had Comet Lovejoy, a different Lovejoy comet that was just unbelievable. The tail on that thing was what? It was like 90 degrees long.
Oh, yeah, it was.
In the sky?
Yeah.
I mean, there are pictures of it from the space station just ripping across the Milky Way. It was unbelievable. And that's the other thing that was really great about it, too. It rode right along the Milky Way galactic plane. So it was silhouetted by the Milky Way. And you know how much of that we saw in the Northern Hemisphere? Nothing. That's
Zero.
right, big fat zero. So we can be happy about Comet Neowise. So if anyone has anything else to say about Comet Neowise, let's do it now. Otherwise, let's move on. Mallory, you got anything to add?
No, not that I know of.
I think it could be a really great comet, and we're hopeful because we've had a lot of failures this year. So moving on real quick, I'm going to show an image that we have shown you before, but not this version of it. So this is a project that we've been working on at Frosty Drew. And this project is one that Mara helped us out with. So Mara's got some credit in this as well. I'm going to share this real quick with you. And this is the Messier 8 field is what we call it. So there's a lot more than just Messier 8 in this field. Now, in this image here, this is about 15 hours worth of exposure, possibly even more. And this is a series of objects that sit along a part of the Milky Way galaxy called the Sagittarius Arm. Now, when you think about the Milky Way galaxy, we're about halfway in between the Milky Way galactic nucleus and then the outer edge of the galaxy. And we sit right off of an arm. We're kind of on this little spur that comes off of one of the arms. It's called the Orion spur. But in between us and the galactic nucleus, there are two other arms. There's the Sagittarius arm, which is closer to us. And then there's the Scutum Centaurus arm, which is closer to the galactic nucleus. And they all sit along the same plane. This is an image right here of the Sagittarius arm of the Milky Way. And in this image, we have a series of different objects. The first object we have is this one right here. This is actually Messier 8. This is called the Lagoon Nebula. This is about 4,700 light years distant from us. And this is a very active star-forming region. It's a nebula where stars are actually forming. And in this nebula is one of two naked eye visible star-forming nebulae in the northern hemisphere. It's a summertime object, and this is on the front side, or the side closest to Earth, on the Sagittarius arm. There's a lot going on inside this nebula. You have all these dark wisps. But what's really interesting here is this section here, all of these little stars you have here, these are all stars that formed inside this nebula, and they're emerging from the gas cloud. Most of the stars that go through modern star formation all goes through this. But when stars form in these types of nebulae, they're usually buried inside the gas cloud. It takes a while before their combined stellar winds actually start blowing the gas away, and what emerges is a cluster of a few thousand newborn stars. In this case, that cluster is starting to emerge already. Now, in this image, go ahead, Derek.
I was going to say, if you've been to Frosty Drew, you've seen this, and we typically call out the open star cluster that's kind of in front of the nebula, and then behind it you have a very faint faint glowing area that is the visible part of the nebula that we can see through the telescope. The camera pulls out way more information and detail than we can present to the human eye with the telescope.
Oh yeah, absolutely. I mean, like I was saying, this is we're talking 15 hours, I believe this is, of exposure, and that's a lot of time to be able to pull out this level of detail. And as Derek was saying too, what you do notice in the telescope, you do notice this part here. It's like a blurry star. You notice the open star cluster. You notice this little dust lane here, but you're not going to see it in color either. Your eyes are going to see this in black and white because it's very dim. But aside from this in this field, we have this object up here, which is called Messier 20, or the Trifid Nebula. And the Trifid Nebula is quite similar to the Lagoon Nebula, except that this is about 5,200 light years distant from us. And this is on the backside, or the farther side, of the Sagittarius arm. So when you look at this, you're looking across the plane almost. They're not just all at the same distances. You're looking at two separate distances here, which accounts for some of that size difference as well. When you look at the Trifid, though, you're looking at a star-forming nebulae that's extremely young. This is probably one of the youngest star-forming nebulae that we can see so brightly in the sky. And, the blue light you see here, this is just starlight illuminating the nebula from the high-mass stars, the blue stars that form inside here. And then the red parts you see, this is a product of ionized hydrogen that recombines. So you figure you get some ultraviolet radiation that comes off these high-mass stars. They smash into these hydrogen atoms and they blast the electron off, an electron off the hydrogen atom, and gives it a negative charge. Now you got a negatively charged ion and you have a free-flowing electron, and they want to reconnect. And they don't necessarily reconnect with the same electrons and the same ions, but they will reconnect, an ion and electron. And when that happens, they get, it's called an excited state. And when they return to a ground state or a restful state, they release a little bit of energy, and it's a photon, and we can see that. And that's all these reds that we see. So it's just recombined ions from ionization in the gas cloud. But other things we see here, we have this section over here. I believe this is called NGC 6500. And what you're looking at here is another molecular cloud. It's hydrogen gas, but it's not so much star formation here. Largely what's happening here is you have a lot of stars. You know, we're looking into the galactic plane here, so there's stars everywhere. A lot of the stars inside this area are ionizing the gas cloud. And right here, this bright binary star right here, there's actually two stars right next to each other, as a proper motion and the movement of that hydrogen cloud connect, a little bit of like a bow shock forms around the front of that area. And that's what you're looking at. You're looking at the edge of the stellar winds of those stars, where there's enough ultraviolet radiation to actually interact substantially with the gas cloud around it. All these dark regions you see out here, this is not gaps in the arm. This is all cold hydrogen gas, and we call it a dark nebula. And this dark nebula is actually obscuring our view of stars beyond. You have a lot of it right over in here, all over in here. You got tons of it out here. And even in this area here, this is all largely dark nebulae. This here is a little globular star cluster. And up here, we have an open star cluster. I think this is Messier 23. I'm not too sure. And then down here, if you were to look at this from a point of view of the Milky Way galactic plane would actually move kind of in this angle here, because we don't orientate our camera with the Milky Way galactic plane. We orientate the camera with Earth's axial tilt. So when you look out in this area here, you have what looks like a lot of white cloudiness around the star here. A lot of this white cloudiness is what we call the integrated flux nebula. You also see a lot of it in here. And the integrated flux nebula it's a recent discovery, because you really need a very modern camera to be able to capture it. And what it is you're looking at nebula, hydrogen. I mean, everything's hydrogen, right? It's hydrogen gas that's not being illuminated by any one star. You know, it's like you got these stars here are the product of all this glow you see here. Same in here, the stars that are forming in this nebula. These stars over here are responsible for all this glow in here. But you can't bring the glow of the integrated flux nebula back to any one grouping of stars or any individual star. It's just the overall background light of all the stars in a galaxy that is just very slightly illuminating it. And the more sensitive our sensors get in our cameras, the more of this integrated flux nebula we just see everywhere. Now, Mara did a lot of work with me on this project. One night she did, you know, the setup of the mount. She did the alignments. She set up the data capture. So I'd say a good 3 to 6 hours of this data collection is from Mara. So way to go, Mara. Thank you. Now, I'm going to stop presenting right now, and we're going to turn it over to Derek if he's got any stuff to show.
Well, I was looking through my data, and I don't have anything, like Scott was also saying, he doesn't have anything new, but I can go over some of the stuff that I've got. I kind of want to bring up some of the stuff that we're going into in the summer here, and we'll be showcasing at Frosty Drew. So let's see if I can figure this out again. Chrome tab. All right, let's do this. All right, so this is kind of a gallery view of some of my astrophotography. This picture over here is similar to what Scott just showed you. This is my version of M8 and M20. But what I wanted to come down to is kind of this section. We've got M27, which is the Dumbbell Nebula, and that one is a nebula that's in the summer triangle, kind of in the middle between Deneb and Altair. And if you're familiar with the summer triangle, if you're looking towards the east, those are the bottom two stars, the right hand and left hand star where Vega's above you. And then later in the summer, we're going to have this object over here. This is M31, the Andromeda Galaxy. This is the closest full-fledged galaxy to the Milky Way. It's similar in structure. This is a spiral galaxy. I think the current theory on the Milky Way is a barred spiral, which means that our center structure is a little different than the Andromeda. And the Andromeda galaxy is a little bit larger than the Milky Way. The Andromeda galaxy has 2 satellites. You can see the first one here, which is, I think, M110. And then the other one up here in the upper left is M32. And through our telescopes, you can really start to see some of this this detail in the structure of the Andromeda galaxy. This is another picture of the Andromeda galaxy, and then this one here is M33, which is a little bit later in the year, not by much. This one is probably about a month behind Andromeda to get to the same spot in the sky. It's a much dimmer galaxy, but we can see it in our dimmer and smaller galaxy, and we can see this one in our telescopes a little bit. Let's see. Over here we've got M57. This is the Ring Nebula. If you've been to Frosty Drew, you've probably seen this. This one's in the constellation of Lyra, which is anchored by the bright star Vega. I show this one quite often with the 8-inch telescopes that are in the yard, and a lot of people, when they see it, it looks like a smoke ring in space. So this kind of gives you a better idea of what you're looking for when we're showcasing that object. Let's see, what else do we have?
Derek, these are fabulous images.
Thanks. I got a lot of these done this year. We had a nice stretch of about 6 days where we had probably the best skies I've seen in a while that close together. So I loaded up on data, and it's taking me a while to process through it. This is kind of a cool one that happened recently. This is a galaxy in the Virgo constellation that went through and had a supernova. It wasn't a type 1A, it was a type 2 supernova. But I plan on taking a picture of this later and seeing if we can do a comparison and see that that star, which is the supernova, not being there, and then have the side-by-side comparison.
Derek, is there any way to make those a little bit bigger? So when you're talking about that one to...
Maybe. I think if I open it in a new tab, it's going to... I won't be presenting that tab. Let's see what happens. Okay. I assume you still see the gallery view?
Yeah. Yep.
Yeah. All right. Sorry. I'll have to remember that for next time.
That's fine. It's just small. I'm sure everyone would like to see it a lot bigger.
Yep.
But if we were looking at these in a telescope, they would appear small like this. I mean, these galaxies are out there. It's not like things in the Milky Way where we're saying, yeah, this is 1,000 light years or this is 10,000 light years. These are millions, tens of millions of light years. I mean, Andromeda, like Derek was saying, closest full-out galaxy to us, 2.5 million light years distant. Think about that.
Yeah, and this is actually about 5 full moons wide. This is a very large object in our sky, but we can only really see the core of it in the sky, naked eye, and then through binoculars you can start to see more of it, and then through the telescope it really helps to pull in the faint details in the arms. And some of the cool things you can see here, there's star clusters out in the outer arms here that actually stand out against the blackness of space and can be seen. It's kind of an interesting challenge. Another object that's pretty popular in the summer at Frosty Drew is this one here. This is M13. This is the globular cluster that's in the constellation Hercules. We show that one probably not this time of year because Hercules is straight overhead, and when a constellation is straight overhead, the Dobsonians are pretty hard to handle. They kind of fall all over each other.
When we do our telescope training, we make all the trainees go after M13 when it's at zenith, so they can suffer.
And it basically goes right through the zenith. It'll go right overhead. it's a fun one to try to keep track of. This is the other star forming region in our sky that we can see naked eye. This is the Orion Nebula. This is a winter object, and you commonly know it as the Sword of Orion. So it's below the belt, and the area of the sky, it looks fuzzy because there aren't any stars there to resolve. It's actually a nebula that we're seeing naked eye. And then two galaxies that I try to get to over in the Big Dipper area. This is M51, and this one's pretty neat because it's kind of going through an interaction where you've got this satellite galaxy that has interacted with the primary galaxy. And then the other one is a little lower. It's M101. It's much larger and fainter. And they're pretty close together in the Big Dipper off the end of the arm. So.
Yeah, I think that other galaxy picture you just had up was awesome. That one, that's one of my favorites that you have.
51.
Yeah, it's beautiful.
That's actually quite a looker in the telescope too at Frosty Drew. That's one of the few galaxies we look at where the spiral arms are quite apparent visibly in the telescope. So,
yeah,
I mean,
it's really awesome because it has such deep dust lanes that it really provides the amount of contrast that you need to be able to see those with your naked eye. Well, not naked eye, but your aided eye with a telescope, because otherwise you just don't have enough light to form the contrast to be able to see the detail. Sorry, I keep scrolling. That's really annoying.
Now, Derek's got these images here of the Andromeda Galaxy. And when we're at Frosty Drew and Andromeda rises high enough in the sky and we don't have the moon up, we can actually see the Andromeda Galaxy naked eye. And like Derek was saying, you're looking at the galactic nucleus. You're not seeing the whole, 5 full moon width of the galaxy. But that's the furthest thing we can see there. I mean, everything else we see in the sky is in the Milky Way. And most of the things we see regularly in the sky are in our little neck of the Milky Way. Like they're in our little circle of activity. The Andromeda Galaxy, that's millions of light years away. So, yeah. I mean, think about that the next time you see the Andromeda Galaxy, that you're looking at something that is 2.5 million light years distant. And your view is 2.5 million years in the past because it took that long for the light to cover that distance. I mean, that's how far that is. Now, we have done some viewing of, so Derek was mentioning the Orion Nebula is a wintertime object. It's like the de facto wintertime object. But we have seen it in the summer at Frosty Drew. Typically, right at the end of the summer, in August, or a Labor Day weekend, when they have the Rhythm and Roots Americana Music Festival, which I don't think will happen this year. But during that event, we used to stay open all night long, and we would get our first view of the Orion Nebula in the morning hours during that event, because Orion starts to rise before pre-dawn that time of the year. Yeah, these are great objects, Derek. So I have a couple of videos here of Jupiter and Saturn. These are videos that I've captured over the last, I'd say, a couple weeks to a month. And yeah, that'd be amazing if that one was it. Dig it up here real quick.
Hey, Scott, we have a question here from Mark. He said, what's the farthest object you can see at Frosty Drew?
The Andromeda Galaxy.
How far away is it?
It's 2.5 million light years distant.
With the telescopes, we can see things hundreds to thousands of light years away.
That's right. So is he asking in the context of the telescope or just naked eye?
He just asked the question, so I'm not too sure.
If it's at Frosty Drew Observatory, then yes, I'm sorry. Derek is right. That we can see things as far as our telescope can capture the light from. Now, this really kind of depends on a lot of stuff. Most of the objects we look at they're in the Milky Way galaxy. I mean, typically, we're looking at objects that are close by. The furthest things we look at regularly are galaxies, and most of the galaxies that Derek has been showing. But occasionally we'll take a look at some quasars. And quasars are, it's not so much that they're distant. Quasars are largely from the earlier universe. And quasars are it's a young galaxy that has a very, very active, very, very massive central black hole. And around that black hole, there's a very large disk of matter that's moving quite quickly. And it's becoming very hot as that matter starts to draw up to the edge of the black hole called the event horizon. And it heats up enough to emit a lot of light. We've seen a couple quasars at Frosty Drew, and these are the furthest objects that I've observed there. And there was one back in, I think it was 2017, in the constellation Pegasus. The quasar was called CTA-102. And it's not visible usually. It's only visible for a couple weeks, I think, every 10 years. And we timed it right, and we actually got a view of it in the telescope. Now, it looked just like a little dim star. But this quasar is 8.5 billion light years distant. And not only is that the furthest thing we've ever seen in the Frosty Drew telescope, that's the furthest thing I've ever seen and will probably see in my entire life with my eye. Like, not using another form of, like, you do data collection on the early universe, but you're looking at the product of that. You're not looking at that with your eye in real time. This quasar, 8.5 billion light years away, we're looking at that in real time. And a good way to think about that is that sounds really like, oh yeah, great, 8.5 billion light years. And we toss a number around. But that light has been traveling so long that the view of that object is so far in the past that we're seeing that object as it looked over 4 billion years before the sun formed. That's how old that view was. I mean, it's 8.5 billion years old. I mean, that's how far that is. That's redonkulous. So
It is really hard to wrap your brain around that number.
I mean, it is. It is. It's crazy. It's out there. So here's Saturn. So this is a view of Saturn from about maybe a month ago, maybe a little less than a month ago. And this was in the primary telescope at Frosty Drew. Now, when we capture images of planets at Frosty Drew, it's a lot different than it looks when you're actually observing it. So we capture these images using filters in the different wavelengths, and we use a monochrome sensor or a black and white sensor. And then we rebuild the color parts of the image up in our pre-processing steps. Now, this image here, this is the green wavelengths of Saturn. And the reason I chose to show you the green wavelengths right now is because most of the detail on Saturn that you see are in the green wavelengths. And you also have a lot of stability in these wavelengths. Now, in this image here, you can see just a little bit of a hint of the equatorial bands on Saturn. Obviously, you can see Saturn's rings. And this image is upside down. You can see a little bit of a gap in the rings right here, like a little black line in the rings. Right in here. This is called the Cassini division. And this is an actual gap in the rings of Saturn. That right there, that's how I kicked the telescope, sorry. And so this is, that Cassini division is really it's really awesome. It's quite large. Now, when we process this data up, we'll be able to clean it up a lot. We'll be able to see another gap out here called the Encke gap. Now, Saturn has reached a point now where its tilt from our point of view looks like it's starting to recede. Now, Saturn's tilt doesn't actually change, but since it takes Saturn 30 years to get around the sun, we catch up to it every year. Our view of Saturn's tilt changes. So the orientation of Saturn from our point of view as it relates to its tilt will change. And we'll see Saturn's rings go from a maximum tilt of 26.7 degrees towards us to 26.7 degrees away from us over a period of 15 years. So Saturn was at its maximum tilt towards us back in May 2017. And so Saturn's tilt has been receding. And just starting this year, you're starting to just get it. So this is upside down. So this is tilted towards us. So this would actually be on the bottom of our view right here. Don't kick the telescope in your imaging, guys, really. That messes your data up. right down here on the bottom, he's just starting to see some of Saturn emerging below the rings. And over the next couple of years, that'll happen a lot. So Saturn is something that we look at in the Frosty Drew telescope. It is hands down the most popular object we look at in our telescope at Frosty Drew. And it is the one object that we look at that probably evokes the most dramatic emotions in our visitors. And we have people that laugh, we have people that cry, we have people that swear, we have people that attack us. I mean, it's really, and most people that look at it, their first impression is that it's fake because it just looks so detailed in our telescope.
Yep, we hire the best artists.
Now, that's Saturn, but we also, this year, have a view of Jupiter. Let's see if this is it.
Can I interject a question?
Yeah, please, go ahead.
Mark had another question as it regards to like the lockdown. And he says in lesser light pollution, I wasn't sure if he meant light pollution or air pollution, has it allowed you to see objects that weren't so clear in previous years?
So that's a good question, Mark. That's hard for us to answer. We haven't studied that, so I couldn't give you an answer from a point of view of data-backed evidence. But what I can tell you that I've observed very clearly and made our lives a lot easier was the significant lack of air traffic. So when we're doing any kind of imaging over Frosty Drew, especially the wider the field, the more we got to deal with air traffic. And there's a lot. I mean, the main flight route to Logan up in Boston comes over Frosty Drew. TF Green comes over us. And then there's other air traffic going to airports that are either further north or they're flying over to Europe from airports that are south of us. And this air traffic becomes very problematic. During the lockdown, there was a couple nights that I was out there with other team members where we saw maybe one airplane for the entire night. I mean, you usually don't get any time at all where there's just one airplane in view. There's always at least 3 planes in view. And that was a big difference. As far as clearer skies, more stability, I don't think so. Because I think from our location, the number one problem that you would have in New England, even if there were no lights here at all, is the moisture. There's a lot of moisture in the atmosphere over New England, and that becomes problematic, especially in the evening or overnight when a lot of that moisture starts to condense in the air. So even though we might have had much clearer skies, if we were over a very dry location, you might have noticed it. In New England, I would say in the nighttime, no, I didn't really see it. And when we looked at our data sets, they pretty much looked the same, just without air traffic. But the days were beautiful, I'll tell you that.
We had another question too from Tracy, who's with us. I don't know if you could go back to Saturn, because her question was with Saturn.
Definitely.
Said, any idea how far the innermost part of the ring is from the planet? And then she had a second question after that.
So yeah, Tracy. So when you're looking at Saturn, and this is actually a really interesting fun fact about Saturn. Saturn's rings will rise they sit about 166,000 miles off of Saturn's cloud top, so the top of the clouds on Saturn's atmosphere. And that's about half the distance to Earth's moon. Now, that's pretty far, but when you think about that, those rings, if you flip them on their side and look at them directly on, they're 10 to 30 meters thick. But that's how thin those rings are. I mean, that's ridiculously thin. So now when we say 166,000 miles, we're talking pretty much from Saturn's cloud tops to the end of the rings. To the inner side, you're talking probably about maybe 100,000 miles off of Saturn's cloud tops. But in this view right here, we're not seeing the edge of the inside of the rings. There is another band inside that is much more tenuous and much more translucent that once we process the data will become more visible. And that gets much closer to Saturn's cloud tops. And actually the gap in between that ring and Saturn's cloud tops is very small because it kind of tapers off into that region. And the Cassini spacecraft that was out at Saturn for over a decade, which gave us so many amazing views of Saturn, actually squeaked right in between that little gap. And it was quite interesting. And it actually found that the region that it went through in that gap was substantially less populated with ring-type matter than we thought it would be. And it really didn't interact a lot with any kind of debris or objects or impacts in that region.
She responded and she said, wow, I didn't realize the distance was so great. And she had another question too that said, what's the best month of the year to observe and astro image Saturn?
So it changes every year. Like we were saying before, Saturn has that 30-year orbit around the sun. So every year when we catch up to Saturn, it's going to be a little bit further along in its orbit, and therefore it's going to be imposed upon the sky in a location that's further eastward. So right now, I'd say Saturn's best time for viewing is the month that surrounds the period of opposition. Now, opposition is when Earth reaches a point in its orbit where we end up right in between the sun and Saturn is on the opposite side of Earth and the sun. This is the best time to look at Saturn because of two reasons. Number one, we're at our closest to Saturn for our year. Secondly, it is up for the entire night. Saturn on the night of opposition will rise at sunset and will set at sunrise. And additionally, Saturn is in completely direct sunlight from our point of view. And Saturn's opposition is, I believe it is July 20th. Yep. So we're talking about 10 days from now. So we're in that window right now.
Jupiter is the 14th.
Yeah, Jupiter is this week, the 14th. So now is the best time to be looking at Saturn. Now is the best time to be imaging Saturn. But for those that don't want to stay up late right now to catch a view of Saturn, after opposition, after July 20th, Saturn will rise before sunset. So once the sun sets, Saturn will already be readily visible, and that'll make it a lot more accessible to those that don't want to be out until midnight or the early morning hours.
Because at Frosty Drew, we have to wait a little bit after it rises because we have trees, unfortunately. And you get a better view when the planet is not low against the horizon. Once it gets above the horizon, we're looking through much less atmosphere, so much less turbulence, so we get a much clearer view of the object.
Right. I mean, kind of one of the banes of having Saturn in the summer sky for so long is that during the summer, the ecliptic, which is the path the sun takes across the sky, the plane of the solar system, so all the planets are on it, is very low in the night sky during the summer. You think about it, the ecliptic's altitude in the sky is a product of Earth's axial tilt at 23.4 degrees. And in the summer, we're tilted towards the sun. But that's during the daytime, where we get the sun really high in the sky because of our tilt towards it. The nighttime side of Earth now has the ecliptic really low in the sky. So having Saturn in the winter sky, up nice and high, almost around 60 degrees, that's that. So the image I just threw up right now, this video, this is actually from back in May, and this is when Mercury was visible. And this is higher resolution than I was capturing Venus at, for those who may remember all the Venus data that we were showing when we were doing our lockdown live streams. That's how small Mercury looks comparably. And though it is further away from us in Venus, it's a lot smaller. And this, I still haven't processed this data set out, but once this is processed, we'll be able to get a nice view of in this case, the gibbous phase, and possibly even some of the cratered surface of Mercury. Now, that's largely all I have right now. You guys have anything else to add?
Out.
There's one thing There is one thing I'd like to debunk real quick. So summertime brings around a lot of kind of hokey ideas about space. They're usually based on some old email that went around at some point that didn't have a year attached to it, just a month and a day. And recently, we've been getting a pretty good amount of inquiries about this alleged planet parade that's happening, where you got all these planets on one side of the sun, and this is a super rare, crazy event that never happens, and you want to get out and see it while you can. And this is all nonsense. First of all, scientists don't call it a planet parade. We call it eastern elongation and eastern quadrature. And that's what happens when all the planets are on one side of the sun. But that's not uncommon. I mean, you get the planets on one side of the sun all the time. The next time it's going to happen is going to be in 2021. So the last time it happened, I think, was maybe 5 years ago. It's not all that uncommon. So if you're interested in seeing the planet parade, you're not even going to see it, because all the planets are not going to be together in the sky. By the time you have Venus rising, Jupiter and Saturn have already set. So you're not going to get them all in the sky at the same time. It's not like there's going to be a grouping of all these planets. And another thing, too, has been called an alignment. It's not an alignment. Having all the planets on one side of the sun is not an alignment. If you had all the planets, like when we reach opposition for Jupiter and opposition for Saturn, that's an alignment. The sun, the Earth, and whatever outer planet is we're in opposition with is in alignment. And if you get the moon, either new or full, doing that, then you get a little bit of a bonus added to that alignment. But it doesn't mean that the ocean is going to swallow up the Andes and the Himalayas. It just means that we get a really great look at the outer planet. So if we have nothing else to add at this point, we're gonna wrap up our session. We're sorry we started a little late tonight. We went a little over in the end, but we were excited about the prospect of having another night. Now that we're in phase 3 of reopening Rhode Island, we're actually able to host a max of about 240 people on our campus. Now, that's not what we're going to start with. We're going to phase up to that. And we're going to try to shoot for an event with 120 visitors. And what we can do now is we can space out telescopes a little bit less dramatically. We can increase the number of people that are at each telescope station, but it's still going to be very limited compared to what you're used to seeing at Frosty Drew. We've also had inquiries about our Perseid event that we host every August and is very often clouded out due to all the wildfire smoke we get that time of the year. We haven't figured out our Perseid meteor shower event yet, and the information on our website is currently accurate as far as the event goes astronomically, but it's inaccurate as far as how we're going to host the event. We'll figure something out, but we're not clear yet on how we're going to do it. But we were hoping that we get to see you guys out soon. We're trying to make the ticket system as easy as we can. The reason why we don't post them right away is because we want to make sure that everyone has a chance to buy a ticket to come and see us, but they don't sell out weeks before the event. And I also want to thank all you guys for tuning in and spending time with us, and for being patient with us, even at the times we get snippy, because we're stressed out with everything that's going on, and we're trying to make it work for you guys. And sometimes we got to step back and we've got to remind ourselves that everybody's in it with us, and that we just need to, chill out a little bit. But we're looking forward to the reopenings that are taking place. We're looking forward to the higher numbers, and we hope to see you guys all out under thousands of stars with us ASAP. And like I said, check our website for tomorrow's event to celebrate the Milky Way event. We're going to try to be as liberal as we can with our schedule. And even if it's not awesome skies to view the Milky Way, we will open for a couple hours just to show you guys some of the planets and binary stars and anything else we can put our telescopes at. So until then, have a great night. And I hope the storm just doesn't even come through, right? So we'll see you guys soon. Good night.